So today we're talking about dilations and scale factors. So I know this is something you've seen in the past. It might have been a while ago, so you might not remember how to do it, but I know it's something you've at least seen before. So whenever we have a transformation that makes something bigger, an enlargement, or reduction, which makes something smaller, it's called a dilation. So dilations are always denoted by this symbol. So this is the prime. So that just means it's our second image, or it's the image after we dilated. So this blue shape, notice that the letters do not have the little prime sign. So that's our original, or our pre-image. The red shape here, this is our image, or our new shape after we've dilated. So this is a dilation that is getting smaller, so it would be a reduction because it's getting smaller. So triangle JKL is the original, and J prime, K prime, L prime is the image, like I just said. So if I wanted to find the scale factor, what I need to do is I need to find wherever the center of dilation is. If it doesn't tell you where that is, it's just at the origin, or 0, 0. So a lot of times it's going to be there. So wherever the center of dilation is, I find the distance from one of the prime points. So I could go from, this is the C, this is the center of dilation up here. So the distance from C to J prime, let's say. So I could do C, J prime. Divide that by the distance from C to the original J. So C divided by J, and that will give you the scale factor. So this should be smaller than 1 because it got smaller. If it's getting bigger, the scale factor will be bigger than 1. So in example 1, we got to find the scale factor using this as our center of dilation. P prime is our image, or our new dilated shape. P is the point from the original, or the pre-image. So remember, the scale factor is equal to CP prime divided by CP. So the length from C to P prime would be 12 plus 6, which is 18. The length from C to P is 12. So if I reduce the fraction, so remember we never want to leave fractions that we can reduce, so always reduce fractions if you can. 6 goes into both of these numbers, 6 goes into 18 3 times, and into 12 2 times. So our scale factor would be 3 over 2. For example 2, we got to find the scale factor and then tell if it's an enlargement. Oh, we had to do that on this one. So this is obviously getting bigger, so our new image is bigger, or our scale factor is bigger than 1. 2 ways to look at it, so it's an enlargement. So example 2, find the scale factor and then tell whether it's an enlargement or reduction, and then solve for x. So here's our center of dilation, here's our P prime, so the length from C to P prime would be 8 plus 4, which is 12. And the length from C to P is 8. So if I reduce this fraction, 4 goes into both of these numbers. So 4 goes into 12 3 times. 4 goes into 8 twice. So our scale factor is going to be 3 over 2. This is obviously an enlargement because our new image is bigger. So it's an enlargement. And then to find the value of x, if this side is 2, and our scale factor is 3 over 2, so whatever the length of each of these sides are, I would have to multiply it by the scale factor to get the new side. So 2 times 3 over 2 would equal x. So if you want to multiply a fraction times the whole number, you can just divide the whole number by 1 and then just multiply across. So 2 times 3 is 6. 1 times 2 is 2. 6 divided by 2 is 3. So x is equal to 3. So moving on to the next page. So example 3, we got to find the scale factor, tell if the dilation is an enlargement or reduction, and solve for x again. So here's our center of dilation right in here. So here's C. So remember, scale factor is CP prime divided by CP. So CP prime would be this length right here. It tells us that that is 8 from C to P prime. From C to P, that length is 24. So 8 goes into both of these numbers. 8 goes into 8 once. 8 goes into 24 3 times. So our scale factor is 1/3. So our scale factor is less than 1. So it's going to be a reduction. Oops. Or you could just write out reduction. Also, you could say that the original, so the p with no prime, is bigger than the green shape here with the p prime. Then we got to solve for x. So we're trying to figure out what this original shape or original side length was. The new one, the smaller one, is 4. So if I knew, well, let's just say this. I know the scale factor is 1/3. The original side was x. So if I multiply the original side times the scale factor, that will give me the new side. But the new side is 4. So x times 1/3 is equal to 4. To get rid of a 1/3 or a fraction, I'm going to multiply by the denominator. So I'm going to multiply both sides by 3. 1/3 times 3 is just 1, so that'll go away. So x is equal to 4 times 3 is 12. So x equals 12. So sometimes you'll see this type of notation for dilations. If you ever see this, n is the scale factor, and the center of dilation is the origin, most of the time. Or this would be the center of dilation. If they had an ordered pair in here, that would be the center of dilation. So for example, in example 4, our scale factor is 2. And the center of dilation, since they don't say, they just say shape, the center of dilation is 0, 0. So we need to look, do these points have primes on them? They do not. It's just A, B, and C. So that means this is our pre-image. This is our original shape. So that means I need to find the new one, the image. So I have to multiply each side by 2. So one way to do this is figure out each point. So A is at 1, 1. So right 1 up 1. B is at right 2 down 1, so 2, -1. And then C is at -2, 0. So all I need to do is multiply each of these points by the scale factor, and then that will give me my new shape. So multiply times 2. So A prime will be 2, 2. B prime, so 2 times 2 is 4. 2 times -1 is -2. And then C prime, 2 times -2 is -4, and then 2 times 0 is 0. So these are be the points that I have. So 2, 2, 4, -2, and then -4, 0. 1, 2, 3, 4. So this would be my A prime, this would be B prime, and then C prime. So that's how you find the new shapes. And then finally, 1. This time our scale factor is 1/4. So that means I would need to multiply each of these points by 1/4. So A is at 0, 4. B is at 4. C is at -4, -4. So again, since we should always check to make sure these either have or don't have the prime symbols. So there's no prime symbols, it's just triangle ABC. So that means this is the original. So to find the new one, I would have to multiply by the scale factor. So times 1/4, times 1/4, times 1/4. So A prime, if I multiply 0 times 1/4, I get 0. 1/4 times 4, so I'll do that over here. So 4/1 times 1/4. I get 4/4, or 1. So that'd be 1. B prime, so 4 times 1/4 we just figured out was 1. -4 times 1/4 is -1. And then C prime, -4 times 1/4 is -1, -1. So 0, 1, 1, -1, and -1, -1 would be our new points. So this is going to be A prime, B prime, and C prime. Good shape.